Okay, you are welcome back to Introductory Mathematical Analysis A, and now we are still in chapter 4. And this time around we'll be covering chapter 4.2 and 4.3. Okay, 4.2 and 4.3. Okay, so we are now going to go into session 4.2 and 4.3, which is logarithm functions. In logarithm function, recall that if we have an exponential function, this is an exponential function with base of b and power or exponent of x. Okay, if we have an exponential function, then the inverse of that exponential function is a logarithm function. Okay, now see this inverse. So this is a notation for inverse. Now this one is not the same thing as 1 over f. Okay, so don't convert it to 1 over f from the rule of exponential function we learn. No, this is a notation. This one is a notation to mean inverse. So whenever you see this notation on a function f, is a notation to mean inverse. Okay, so the inverse function of this exponential function is what we call logarithm function to base b. So we have log base b, log x to base b. Okay, this is the base and this is the log of x to base b. That's what we call it, log of x to base b. Okay, take note of that. Now, sometimes we have this log in a common logarithm, okay, which is base 10. So anytime we write log without the base, just know that is in base what? Is in base 10. Anytime we write the log without the base, the log is in base 10. Please don't forget that. Okay. Now, sometimes I told you before that the exponential function exponential function e is very important to us, and so we want to find the logarithm into base e instead of 10. This base can be any base. Okay, when we write log bx, this b can be any base. Could be 2, okay, could be 5, could be 10, as we saw before. Okay, now also it could be e, and this e is very important to us in mathematics and in mathematical finance. This e is very important. So log to base e, log x to base e gives us what we call natural logarithm, which is lean. Okay, we are going to be using this lean a lot. Okay, so lean. So whenever we have log to base e, that is what we call lean. That is lean. Log to base e is called lean. Okay. All right. So sometimes we need to change from logarithm function to exponential function. Logarithm function to exponential function. So take note of this. So if I have this by equals to x, this is exponential function, exponential equation. Okay, we want to change it to logarithm function. In changing to logarithm function, so we have log. Don't forget, this is our base in exponential function. It still remains the base in logarithm function. Now this is the power or the exponent in logarithm function. That will now be what is on the other side of the equal sign. So this x, which is on the other side of the equal sign in exponential function, will now be the log. Okay, please take note. So now we have log x to base b equals to y. But here we have b raised to power y equals to x. So when changing from log to exponential function or from exponential function to log, the base remain the same. The base remain the same, but the exponent becomes the right hand side of the equation, becomes the right hand side of the equation, while the right hand side here becomes the log, okay, the right hand side becomes the log, all right, becomes the log. Let me call it left hand side, okay, all right. This is the power which becomes the right hand side of the log, while the value on the right hand side becomes the log here. Okay, so that is how to change from exponential function to logarithm function. Okay, so when we have this, don't forget this is the base. So we have log 6. This is the exponent, which will become the right hand side, while this is the right hand side here, which will become the log. Don't forget that. Again, 10 is the base, so the base remain the same. Then the exponent become the right hand side. The right hand side here become the log. Okay. The same thing when you have here. So when we have log 3x equals to y. If you want to change it into exponential function, this is the base. So base. This is the right hand side here and left hand side here, which will become the what? The right hand side. That's okay, and this is the right hand side, which will become the power or the exponent. Okay, please take note of that. Please take note of that. All right, so there's a need to interchange from log to exponential function when you are solving some problems. Okay, all right. Now also, if you want to graph the graph of logarithm function, the same way we graph the graph of exponential function, you choose at least 5 values of x, but this must be greater, x must be greater than 0. In logarithm function, x must be greater than 0 for you to get a defined value. Okay, determine the corresponding values of y and then plot the point. Then plot the point and connect the curve. That's how to do. So if you take, for example, this function, don't forget this function means log of x, okay? Log x of to base e, log x to base e. That is what this means. Okay, now if you want to plot the point, you take at least 5 values and then you begin to put it there. You see, this will give us undefined, the negative value, and 0 will give us undefined. So there's no point there. Okay, so now the remaining one will give us this. For x will give us 0, and for 2 it will give us this, for 3 it will give us this. Then you can plot the point. And in plotting the point, you will discover that we have the x-intercept, which is 1, 0. Okay, in exponential function, we have y-intercept, which is 0, 1. But now in logarithm function, we have x-intercept, which is 1, 0. Okay, please take note of that. Okay, so this graph goes like that, but we will never touch the y-axis. Okay, this is our y, and this is our x. Okay, all right. So, but the value of e is greater than 1. Don't forget that. The value of e is greater than 1. Now, let's see another graph that we have less than 1. Okay, less than 1. Again, there's no value for this. Okay, and then when we plot the graph, we still have the same intercept there, which is 1, 0, 1, rather, 1, 0, rather, 1, 0. Okay, but this time around, you see, the value goes on the positive axis like that. When it is greater than 1, it goes on the y, negative side of y, but when it is less than 1, it goes parallel to the positive side of y. Okay, please take note of that. All right, so the properties of logarithm function. The domain of the logarithm function is from 0 to positive infinity, and 0 is not included. 0 is not included. That is the domain. Okay, don't forget this is the range. This is the range of exponential function. This is the range of exponential function. Okay, the range of logarithm function is negative infinity to positive infinity, which is the domain of exponential function, their inverse function. So the domain of exponential function is the range of logarithm function. The range of logarithm function is the domain of exponential function. And the domain of exponential function is the range of logarithm function. Okay, take note of that. There is no y-intercept on logarithm function. There is no y-intercept, but there is s-intercept there on logarithm function. Okay, so if the base is greater than 1, we saw that the graph rises from left to right. The graph rises from left to right. Okay, so that is when b is greater than 1. Okay, let me show you the graph again. From left to right, the graph rises. Can you see that? Okay. Now, when the base is between 1 and 0, less than 1 and greater than 0, then the graph falls from left to right. The graph falls from left to right. You see, we see here now, this goes this way. Okay. All right. If b is greater than 1 again, the graph approaches but never touches the y-axis as y becomes more and more negative. Okay, we saw that before. When it's greater than 1, you see, it goes more and more as y goes more and more negative. And when it is between 1 and 0, we see the graph approaches, never touches the y-axis as y becomes more and more positive. More and more positive. Okay, we saw that here again. More and more positive. Okay, so, and then the inverse of a logarithm function is the exponential function. If it exists, then we call the inverse of logarithm function the exponential function. The exponential function. Okay, please make sure you take note of that. Take note of that. All right.